but we're now going to do it using integration. So you were wondering what was happening last time because it didn't feel like a calc class. It's going to feel a little bit more like a calculus class. Essentially, there are two versions of this question. This is the first one. You've got a single curve from x equals a to x equals b. So you've got this basically shaded area. And you're trying to find the center of mass, which I'm guessing would probably be somewhere round about where that dot is, right? And to calculate the center of mass of the area under a curve, you use this formula. The x coordinate of the center of mass, called x bar, is 1 over a, this integral. Y bar is 1 over a, this different integral. And a is just the area of that entire shaded area. So imagine that you had a function 2x plus 1. So I'm going to draw it, looks like that. And we're doing it from x equals 1 to x equals 2. So okay, imagine there's x equals 1 here and there's x equals 2, right? And we're being asked to find the center of mass of that shape. Okay. So how do you tackle it? Actually, the first thing you do, which I'm calling step 1, is you find the area under the curve, which is called a, which is integral from 1 to 2 of the function. And in this case, the function we're talking about is that straight line. So it's going to be the integral from 1 to 2 of 2x plus 1. Power rule, nothing too difficult here. Evaluated at 1 and 2. If you plug in 2, you get 4 plus 2. Take away 1 plus 1, and the answer we get is 4. So step 1 is actually find the area under the curve A. Pretty straightforward so far. And it's mostly a plug and chug involving integrals. So your second step, step 2, not too surprising, find that guy. And he's 1 over a, the integral from technically from a to b of x, f of x, dx. So I'm keeping this particular example pretty simple. So since a is 4, it's 1 over 4. The integral from 1 to 2 of x, and the function was called 2x plus 1, so we're going to get that. Would you agree probably the easiest thing to do here would be just to distribute the x's? That way we could do a power rule, right? That would be the obvious way to tackle that. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. We got all that stuff. Oh, let's do a guessing game. Let's guess where we think the center of mass might be. I'm guessing about there. So I'm guessing 1.5, and I'm going to guess that. Do you think your answer is a little bit higher, lower, round about that? What do you think it might be? You think it might be 1.54 or 1.51? Any feelings?
I think it'd probably be slightly more to the right because it looks like there's more area there.
Yeah, so more like 1.6 rather than 1.5 here. So we'll say bigger. What about the y coordinate? Do you think 1.5 is big enough, or do you think it should be smaller or less than that? Or does that look good? Anybody get an opinion?
I think
You
you
think-
should be a little bit lower.
Okay. I have no idea what the answer is, by the way. Just getting a gut feeling. Let's see what it is. So what we're going to get then? 2/3 times 2 cubed plus 1/2 times 2 squared. Take away, oh, I'm just going to call that 2/3 plus 1/2 because you don't need to know what the powers are because they're all 1 to the power of something. This is going to be pretty messy. I think I should do it in more than one go then, just to be safe. 2, 4, 8, 16/3, add 2, take away, well, I could do that in 6, 4 take away, ends up being a 6. Okay, should be able to do it now. On the calculator, put a little bracket around it, there's 1/4. Multiply it by a bracket, that plus that, take away that. So 16/3, add a 2, take away 1/6, and then hit math button and fraction, and 43/24, which is very roughly about 1.8. So what was that guessing game we did? Where did I put it? Oh, so the person who thought it should have been a bit bigger was right. It should have been more than 1.5. And I think the argument he gave was good. You know, there's more to the right than there is to the left. And that is X bar done. So I guess no, I've got it here. There's X bar. Well, technically speaking, they want the exact value. So I'm going to have to call it that. Okay. Now the final step, not surprisingly, is to find Y bar. And the formula for that is 1 over A, the integral from A to B, 1/2 the function squared dx. Now these formula are just magic, right? I'm pulling them out of the air and say they work. It's quite difficult to prove that they work, but if you ever do Calc 4 with me, I'll prove it to you if you want, right? But you need to get to a little bit more calc before you can get to a place where I could prove that this is true. So let's see what we have. It's going to be 1 over the area of the under the curve, which is 4. The integral from 1 to 4, 1/2 that guy squared. Oh, wait a minute, that 1/2, I'll bring that outside and make this an 1/8. That way I can just FOIL this out. So that gives me this. And I have 1/8. Add 1 to the power, divide by the new power. Evaluate at 1 and evaluate at 2. So 4/3, 2 cubed, 2 lots of 2 squared, add 2, take away 4/3, 2 and a 1. I think I'll do that. 2, 4, 8, 32/3 plus an 8 plus a 2. Take away a 4/3, take away a 2, take away a 1. I'll just let the calculator do it now. Getting lazy. 1 divided by 8 times, in brackets, 32/3 plus 10. Take away 4/3, take away 3. I get that guy, math, number 1. It's 49/24, which is about, very roughly, about 2.0 to 1 decimal place. So in fact, it's higher up than I thought it was, and more to the right than I thought it was. Okay, now that entire question is the template for finding the centre of mass x bar, y bar. As far as it goes, does that seem reasonable, right? Is it pretty obvious what you need to do? Now, that is a single curve, and I'm going to do one more single curve. And then the final stage is, what about an area that's made by being between two curves, right? What would the centre of mass, would that look like? But that's for later. So let's do x squared. Which is that guy. And let's do it from 0 to 1. Okay. Now, area under the curve is the integral from 0 to 1 of x squared. Simple power rule. And the answer you get is a third. So that's step 1. Step 2, x bar. Okay, it's going to be 1 over a, the integral from 0 to 1 of x f of x dx. 1 over a third. What's that the same as? 1 on the top, all over, 1/3 in the bottom.
3.
Right. So it's going to be 0 to 1. X times x squared gets you x cubed. Add 1 to the power, divide by the new power. And that gets you a quarter. So 3/4. Okay with that one? 3/4. Which would be about here. Well, it should be more to the right. Isn't there more area on this side than there is on that side? So again, it does make sense. Now, the final one, to get y bar, that fella. 1 over a third gets you 3 again. 1/2 the function squared. Bring that to outside, I guess. It's that guy. And that guy gets you eventually 3/10. So the centre of mass is 3/4, 3/10. Now I happen to know that's 1, so it's about 0.5. So 3/4, 3/10. Roughly about there. So the centre of mass of that shape is quite right, you know, right hand side and quite high. Are we okay with, if I gave you a single function f of x from 1 to 2 or 0 to 1, that you could find x bar and y bar, right? As long as you know how to integrate and you use these formulas, everything works out fine. Any questions before I move on? Okay. Then let's look at the final situation. Imagine that we have y equals f of x, and we have another function, y equals g of x, and we're interested in from A to B. So in other words, the area that we're trying to find the center of mass is the area between two curves, right? And I'm totally guessing, maybe there, kind of, sort of, right? But there anyway. Now, there is a formula for it. This is the formula when it's a single curve, right? We're going to adapt this formula, and this is what it looks like. Starts off exactly the same. A is the area between these two curves. You have to go back to week 2, I think it was. Can you remember the formula for finding the area between two curves? One of them's f of x and the other is called g of x. Wasn't a difficult formula. Can you remember what you did?
It's f of x minus g of x.
Correct. Wasn't the only thing you had to be careful was to make the big one on top and the little one underneath. And in my picture, can you see the red one is f and it's higher than the green one, which is g. Great. Now, back to this fella. He used to be called x f of x dx. The adapted version is that one. Does that seem reasonable based on the question? Agreed? Now, this one I think is a little bit less obvious. It's 1/2 the function squared. In this situation, do you notice that you square the functions first and subtract them later? Do you notice that you subtract them as well, right? Are you okay with that? That's just the formula, that's what you do. Okay, so I'm going to use these formulas to find the center of mass for the area between two curves. And whereas the ones that we did earlier were nice and easy ones, I'm going to get you to do this with some really ugly ones. Because if you can do it with the ugly ones, right, the easy ones aren't a problem anymore. So we are going to have y equals 3 sine x, which I guess I should, well, I'll call it y equals. And the other guy is going to be 3 cosine x. And we're going to do it from x equals 0 to pi upon 4. I'll make it even weirder. Let's make it 2x. So if you bear with me, I'll just rewrite that again. Y equals 3 sine of 2x and y equals 3 cosine of 2x. And we want to find the center of mass of what this looks like between 0 and pi upon 4. Well, in that question, I would begin by putting into Desmos and drawing. And if you draw this fella, that's what 3 cosine of 2x would look like. And if you draw the other one, this is what y equals 3 times the sine of 2x looks like. And if you go hunting for it, that point there, very nicely, happens to be pi upon 4. And there should have been another piece here, x equals 0. And what that tells me is I want to find the centre mass of that shape here that's all up there. That looks like an axe to me, right? A big axe head. So we've got an area between a sine and a cosine, and between 0 and pi upon 4. Do you see that does the same job, right? I guess I didn't need to say that. It's already there. So far, so good, right? Now let's see what that looks like. The area under the curve is from 0 to pi upon 4. Cosine or sine, which one goes first? Cosine or sine?
Cosine.
Right, it's the blue one that's higher. Okay, this is going to be a little bit messy, but we can live with it. If you integrate a cosine, don't you get a sine? So if you integrate 3 cosines, you get 3 sines. So you will get 3 sine of 2x. But this is a linear shortcut question, right? Because it's 2x there. What else do you get when you integrate 3 cosine 2x? Because there's something missing from this.
It's 3 halves.
Yeah, 3 halves. The 2's.
halves.
Yeah, the 2's missing or 3 halves. You're both saying the same thing. If you do a sine, don't you get a negative? So that makes that positive. And for the same kind of argument, can I just plug that in and say, call it good? Right. Which means that we're now going to find 3 halves, the sine of pi upon 4, add 3 halves, the cosine of pi upon 4. That's the first lot. Take away the sine of nothing's nothing. And the cosine of nothing is 1. So can I just write 0 plus 3 halves for the second one, because I'm running short of space. So you put 0, you get 0 there. You put 0, you get cosine of 0, which is 1. So you get that. Does anybody know, because you need to know for these questions, the exact value of the sine of pi upon 4?
Root 2 over 2.
And by a nice coincidence, isn't it also the same answer for the cosine? That's typically not true, but it is in this question. Take away nothing, take away 3 upon 2. So far, so good? Right. There is no way this is going to be pretty. Would you agree? It's pretty messy, but I can do something. Can't I join them together? Right. 3.5 this fella, 3.5 this fella. So what would I get? Well, I'd get 3/4 plus 3/4. I'd get 6/4, which is 3 halves root 2. Are you happy about these two add up to get that? You comfortable how these two get me that? So we now have A. So far, so good. Right. Let's find X bar. It's 1 over A, which is this. And I'm not even going to try and make that pretty. Just call it 1 over A and forget about it. From 0 to pi upon 4, X times 3 cosine 2x, take away 3 sine 2x. That's not pretty. You agree? In fact, it's probably a good idea to do two separate questions. How would I integrate just this piece, the front piece? What method? Oops. Must be a method, right? Can't be impossible. What method works?
You're forgetting the name of it, but you split it into the two separate equations. And
Oh, what? The name you're hunting for is integration by parts.
Yeah.
Yeah. In a way, not remembering its name's not a biggie as long as you know what to do. So that works for me. So I'm going to call this F, I'm going to call this G, and so it's integration by parts, which is F big G take away F dash big G. So what's that going to get me? It's going to get me, leave this guy alone. If you integrate a cosine of 2x, you get that. Take away the derivative of 3x and the integral of cosine 2x gets me that guy. That means we have this piece, and I guess I'll just have to use a line up that piece. And now we have this fella here can also be integrated, and what you get is negative makes that a plus. You get another 2, so you get that. And now you can evaluate it at 0 and at pi upon 4. And what we got? 3 upon 2 times pi upon 4 times the sine. Oh, I forgot to double that. Pi over 2. 3/4 cosine pi upon 2. If you plug in nothing, you get nothing here, and you get a 3/4 there. So I get 3/8 pi, the sine of pi upon 2, plus 3/4 cosine of pi upon 2, take away 3/4. Sine of pi upon 2, nothing. Pi upon 2 is 1. Cosine of pi upon 2 is 0, so I get that. So there's my x bar. Well, actually not my x bar. Haven't I only found the first half of the puzzle? Are we good at least with the first half? So what I need to do next is find out what this piece is. And I'll do integration by parts on that fella. And what will I get? I'll just jump to the answer. Every sine will be a cosine, every cosine will be a sine, and it will switch as well. So that will get me a 3/8, because that'll be a cosine. No, that'll be a cosine, so that'll disappear. And that'll be a sine, and that'll get me 3/4, and that'll be added. So I believe, no, that can't be, that's too easy. That'll be cosine, that'll be sine, and that'll still be 3/4. I'm worried about what I think the answer is. Oh, that'll be a plus. Okay, I'm happy now. The answer will be 6/8, which, not 6/8, 6/4. So, add 3/4. Oh, if I've done this correctly, which I hope I have, you've got this ugly guy, and they cancel out, times 3x pi. And that is just x bar done. That's a long question. Okay, I'll start y bar, but I don't think I want to take too much of our time up. It's 1 over a, the integral from 0 to pi upon 4, 1/2, first guy squared, which is this fella, take away second guy squared, which is this fella. That's 1 over this ugly fella. Bring out a half. Okay, that'll put a 2 there. And you get 9 cos squareds. Take away 9 sine squareds. This ugly guy is a little bit nicer. Okay. If you pull out 9 as a common factor, you get this fella. Cos squared take away sine squared. It's a trig identity and it's not equal to 1. If it was plus, it would be, but it's not. Do you know what cos squared 2x take away sine squared 2x actually gets you? Does anybody remember what cos squared x take away sine squared x is?
Cosine 2x.
Okay. So, I'll scratch a piece of paper here. If you use the identity, that's this identity, you can adapt it to cos squared 2x, take away sine squared 2x, it's the cosine of 4x. So it's a cute little trick. Now I'm bringing that 9 out since I spent a lot of time getting it. And I'm going to replace that by the cosine of 4x. I will be able to finish this. It's not as bad as the earlier one. If you integrate a cosine of 4x, you get 1/4 the sine of 4x. Evaluated at 0, pi upon 4. And cosine of pi that's not right. I get 0. Huh? No. There's something that's not quite correct. But the method is right. I tell you why I don't like 0 for the y bar. Where's my picture gone? Here. If the y bar is 0, well, maybe it is right. I guess it could be right. It just means it's there. doesn't look right. I guess I'll just trust the math and it's there. See if I can find one like it. That might tell me if I'm on the right tracks. Yeah, it's not right. The first piece is right. The second piece is actually a number. So somewhere in my calculations, I screwed up somewhere, but not anywhere obvious. So if you come across it, fix it. But the X is good. The X bar at least is good. The Y bar is not 0. Okay, let's okay, let's go for it. I'll do one more example. Y equals X squared, X equals Y squared. Y equals X squared looks like that. X equals, the other one looks like that. If you rearrange this equation, it ends up being that guy. So let's suppose we're being asked for the center of mass of this shape here. Maybe while I'm doing that, something will come to me along the, what did I do wrong in the previous question? Right. Are you happy with this fella being the same thing as that guy? Are we good? Yeah, okay. See if I can, I may not get all of this done, but I need to know that point. Can you trust me that it's 0 to 1? Because you almost guess it in your head. So the area between the two is 0 to 1. Square root is bigger than X squared. That's going to be 0 to 1, X to the half. Because if you want to integrate it, you have to do a half power. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. If you plug in 1, you get 2/3, take away 1/3. If you plug in 0, you get that. We'll call it A, it's a third. Oh. Would you agree that the center of mass is probably going to be somewhere about there? Right. So I want to see a number, might not be exactly a half comma half. I know that guy up there is 1, but it should be down close to it. X bar, 1 over that guy gets you 3. The integral from 0 to 1 of X times f of X, take away X squared. If you just want to watch this video later, I suggest it's probably easier than trying to keep track of me writing so quick. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. And you get 2/5, take away a quarter, minus a whole load of zeros. What does that get you? That gets you 20, that gets you 4 20s. Does that get you 4 20s? Eight 20s, take away 5 20s, so it's 3 lots of 320. Yeah, it's almost a half, would you agree? That seems reasonable. And to get Y bar then, it's first guy squared. Well, if you take the square root and you square it, you get that. The other guy, when you square it, you get that. So it's 1/2 X squared, take away 1/5 X to the 5. from 0 to 1, and that gets you a half, and that gets you a fifth. Take away a lot of the zeros. That's, what's that going to get me? Oh, darn. Turn them into tenths. 5 tenths, take away 2 tenths, gets you 3 tenths. 3 lots of 3 tenths gets me 9 tenths. Something's not right. Oh, it's a half of this. Hey, fixed it. And the answer we get is now 9/20ths. So X bar, Y bar, almost a half, right? Almost in the middle, right? A half comma half, 9/20ths. Is there any reason why you think it makes sense that they're both the same? That the X and Y coordinates are both the same? Is there anything that looks like, yeah, that could happen, that makes sense? And if you draw a line that goes from here to here, doesn't that essentially cut the shape into 2 equal parts? Wouldn't you probably expect the center of mass to be somewhere in that red line? Okay, second one finished well. There's something wrong with the first one. The Y coordinate, the Y bar is not 0, but you're going to have to figure out what I screwed up later. For the last few minutes, let's talk about your test. I'm just loading up my screen. Should be ready shortly. Okay, let's put you on it. I would think by now most of you are familiar with the way tests work, so I don't need to go into the don't cheat routine, right? You know what's allowed and what's not, same rules as always. You're going to turn up at the same time, Zoom, same thing. Everything else pretty much exactly as all the others are. Let's kick this one in, maybe make it a little bit bigger. Get that out of the way. And let's look at our test. Seven 6 is optional. That means it's not going to be in the test. There won't be any questions from integration using tables. But if any of you want to get 2% extra credit, you might think seriously about doing that section. We are going to do improper, arc, surface area, and what we've done today, right? That's the last thing. There are 4 sections that you're going to be tested on. So 4 questions, 1 from each section.